Today I'll be showing you guys how to create a one-button click vine system where you just click on wherever you want and it will draw vines for you. Spawn some flowers, and just like that, you can have vines going across the surface and it actually conforms to it, as you can see right here. So let's get right ahead and get started. But to get started, of course, we need to go to Edit, Plugins, search for PCG, and make sure we have Procedural Content Generation Framework PCG turned on, as well as the Geometry Script Interrupt for PCG. Make sure both of these are enabled and restart your engine as needed. The Geometry Script Interrupt is needed because we're going to be sampling the meshes, and that's where that node lives. Then let's go ahead and get started by right-clicking, going to PCG, grab ourselves a PCG graph, and we'll make an empty graph. It's going to be our PCG underscore vines. Now, we're actually going to need this in the world as well, so I'm going to just take this and drag it out, because basically the vines that we're going to be spawning are going to be inside of this volume. So I'll just go ahead and kind of lift these up. And what I'm also going to do, I'm going to drag in a few meshes here, so we can have a few things that we can kind of move across. I'll say something like this. The only last thing I'm going to do here before we get started with the PCG graph itself is I'm going to just select all of them and then go to the detail panel and search for tag and then give it an actor tag and just call this vine. You can sample every single static mesh inside of the volume, but chances are you only want to spawn on certain things, so we're just going to filter out by tag. So if you wanted to have the vines grow on it, use the tag, otherwise ignore it. But with that, let's go ahead and open up the graph itself. The first thing we're going to do here is not in the graph itself. It's going to be on the right here under tool data with nothing selected. Go ahead and open tool data. Let's give the tool a name. I'll call this vine spawner, and the tooltip will just be click to spawn vines. The compatible tool tags is which tools we want to use. We're going to be using the paint tool. So I'll type in paint tool just like that, and then we'll go ahead and add it to an actor. That is fine. I'll just call this PCG vines. This is what the name is going to be in the outliner once we spawn it, and I'll turn on is preset. So we just have a convenient button for it. When you have all of this set up with nothing selected, you should be able to go in the top left corner and select PCG or hit Shift 9, and then you'll be able to go to paint, select the paint option here, and you should see vine spawner. If you see this here, that means you've done it right. And also in the outliner here, you'll see that's the actor's name, and that's the original PCG vines graph that we created. So the actor is what we can now click on in the world, and the PCG vines with this icon here is the actual kind of box that we have here. So the first thing I want to do is go ahead and sample all of these static meshes and make sure that I have the points of these meshes. And to do that, we'll actually use a loop, because we're going to loop on every single one. So we'll go to right click PCG graph, again an empty graph. I'll call this PCG loop underscore sample meshes, and I'll go ahead and take it and just drag it right into our empty graph here and select the bottom loop node option, and then we'll just double click to open it. For the input here, I have three inputs. The first one is labeled static meshes, which is a loop with an attribute set, because we're going to be sending in the static meshes through here, and we're going to looping in all the static meshes. It is set to required. The second one is the actor location, which is set to loop as well, but this one is on point for allowed types, also set to required, because we need to know for every static mesh what are the locations that are associated with it. So there'll always be a static mesh actual attribute and a position of those static meshes, so these will match. And the final one is the sampling count, and just how many samples do we want to do, so that way when we end up reusing this node down the line, or maybe in a different project and you migrate it over, you can control dynamically how many samples you want. And the output here is very simple, just a normal point that is set to pin status normal. Okay, so with that, let's go ahead and get started here. It's gonna be very simple. All we need to do is right click and search for a mesh sampler, and then I want to open it up, and I want to take the static meshes here and plug them into static mesh, and I want to take the sampling count and plug it into this one, sampling radius. So sampling count, sampling radius, and static meshes to static mesh. I'm going to close these up, and in here in the mesh sampler, we're going to change a few things here. The sampling method I'm going to change for 1 point per triangle to Poisson sampling, and if I open Poisson sampling here under sampling options, we've overridden the sampling radius of the sampler. So basically, the bigger the number, the fewer points there will be, because there's a bigger radius between each point. That's kind of the gist of this value. When we go ahead and set it up in a moment, you will see the actual samples, don't worry. But this mesh sampler actually puts them at origin. It doesn't put it at the location that we want. So for every single one of these mesh, we want to do a copy points node. The source will be the mesh sampler, and the target will be the actor locations. So basically, sample the meshes and then put them at the location where the meshes are in the world, and then output those points all the way through. Okay, with this one done, we can go back to our main graph here, and we can go ahead and hook things up. So how do we get the static meshes? First of all, well, we can do that by right-clicking, doing get actor property. This is normally to get variables, but a static mesh actor in the world is still an actor, which means it has variables like static mesh, so we can grab that information. So we're going to change the actor filter to all world actors by tag, and we're going to do it Vine. Vine is a tag. We're going to select multiple because we want every single thing that is there by tag. And the property name is the name of the variable we want. If I go ahead and select one of these, you can see here in the detail panel, you have static mesh. Then you can right click on this and copy internal name. And then you can go here and paste the internal name into the property name. But you're going to see it still throws an error and saying it doesn't exist. That's because this variable isn't actually on the main actor here. It is on the component. If I click on the static mesh component, you'll see there's a static mesh still. So that information is actually from the component. So what we want to do is actually do static mesh component dot static mesh. So back here, we're going to type in the property name static mesh component dot static mesh. I press enter and you'll see it is no longer complaining. Now if I press A on here and make sure that in the debug object here, it is selected, you'll see there's our static mesh. You see we have a static mesh right here. You only get one here because we have one of those. But if I click this drop down, you'll see there's our 4 different objects and there's our different meshes. So perfect. That is good. Let's go ahead and take that into the static meshes. And now we need to get the actor locations. So I'm going to right click and search for get actor data. This is going to get the information of the points and everything else of the actual location. So just like the other one, we'll do all world actors by tag. The tag is Vine, and we'll do select multiple here. The difference here is we're going to change the mode here to get single point. And if I press A on this one, just like the other ones, we'll get the 4 different points here in the world. And we have to go ahead and take that and plug that in. And the final one is the sampling count. So I'll just hold 1 and left click. That gets us a float constant. I'll just go ahead and change the value here to be 10 and we'll plug that in. And when you do, you'll see this is no longer showing disabled. So we can go drag from here and just add ourselves a debug node. And if I fly in here, you could see there's all our points. They're quite small, but there they are. And if I now grab one of these actors and just hold Alt and drag it over, you'll see there's our points for the new ones. So each one here is going to get all the points. And you can see it goes ahead and puts them across all the objects relatively the same distance apart. Now, one thing to note here is you see how tightly packed they are on this object? If I go ahead and scale this up, the points and everything here gets scaled. So this is something to note that if you're going to be scaling up, the distance from the points is going to increase. If you're only scaling it down, then obviously it will decrease the distance from the points and it'll be quite tightly knit here. So just keep in mind that the scale of it does affect the point spacing here. But that's why that value is exposed. You can make it a parameter and you can dynamically change that as well. I'm just hard coding it for this demonstration because I found that these values just work well for the vines. So awesome. We now have all the points sampled. So let's go ahead and merge all the points together. So they're one big set. So they're no longer separated per mesh. They're just one set of points now. So to use that actual point data, I'll right click, I'll search for get tool data. The tool tag is the same one we used before. So this is paint tool. And the data instance is basically, what do we want to call this layer? I'll call this Vine. Now that that's created, we can go back here and just make sure Vine is selected as our data instance. And I can go ahead and click, and click. Nothing's going to show up. This is purely so we have points for this node, and we can press A now on here. And you can see there's our 3 points that we went ahead and drew. Fantastic. Now each vine is going to need to be sampled individually. We need to draw each one per click in my case. And that means that we need to first split up these points into 3 individual ones. And then what I'm going to do is find a random point that is able to be navigated to, and using the pathfinding node, we'll go ahead and create a spline basically for one to the other. So because we're going to need to do it per vine here, I'll drag out of here and search for attribute partition. And I want to change this at last in the top right here from at last to index by hitting this index button or typing in $index. So every single click will be its own thing. And then we want a new loop here. So once again, in the content browser, I'll right click, go to PCG graph, empty graph. There's going to be a PCG loop main vine. Just like the other one, click and drag it into the graph and select loop node and then double click to open. In this loop, we're going to have 2 inputs. The first one is just called pathfinding points. It is a type normal with a allowed type points that is required. That's the ones that are actually on the surface right now. And then we'll have the painted points. So that's the ones we just clicked on, the ones that we're looping on. So for every single one of these, we're going to be using the pathfinding. And the output here is very simple, just a normal point setup here for the output. So what we're going to do is we're going to filter it by distance. I want to first calculate the distance of all of the points that are navigatable to from the drawn point. I want to see what the distance is to all of them. Then I want to filter out within a certain radius. So that way all of the loops will go a certain distance. And then I also want to possibly filter it so only the points above the current one will be the final result. So it always ends going up instead of going down. You don't have to make it always go up, but I think that's a nice little addition where the vine will always tend to go upwards. Doesn't have to go up very much, but it will go up. So let's start getting the distance. I'll take the pathfinding points here, drag out and search for distance, we want the spatial distance one here. So all of these pathfinding points are the source, and we want to check their distance to these painted points. Now, so I can preview all this information, I'll go back to the main graph and we'll hook things up here. The merge points will go into the pathfinding points, and the painted points here are from the attribute partition. So just like this. So now when we have the distance here, I can press A here on it, and then I can scroll to the right, and all the way on the right here, you'll see distance. So now we know that these are the distances of all of those navigatable points to that specific point. So now from here, we can drag out and search for filter range. It doesn't really matter which one you grab. I can grab the point filter range. It will still be filter attribute elements by range. They're just the same node, just called differently. And now from here, we want to modify this target attribute. Target attribute is going to be distance. And if you select the distance node, you'll see we're outputting the attribute to distance. So great. We'll go ahead and specify target attribute here is distance. And then we'll go ahead and open the max and minimum threshold, and I'll turn on use constant threshold for both of these. You can set it up to be an attribute and expose this. Again, I'm just setting it up to be a one-click setup. If you want it to be more versatile, I do recommend setting it up as attributes and creating those and passing those through. Go ahead and open up the attribute types for both. So the minimum here, I want it to go at least 100 units away. And for the maximum here, I want it to go at most 400 units away. So somewhere in between this range is fine. But like I mentioned before, I also want to make sure that it is higher up this new position than the previous. So this time I'll use a regular filter attribute elements and not a ranged one. And it's going to actually compare it to the painted point. So I'm going to take this painted points and put that into the filter. It's going to complain, but that's because we haven't set it up yet, so don't worry. So what we're going to do is check that this filter's information is correct. We're going to keep it on greater. We're going to hit this plus sign and just need to point position. So we're going to check that the position is greater than the last different thing we used, but we really want to change the position.z, as in the height, is greater than the position of the height of the inside filter here. So we can just copy this and paste it in here. So as long as the inside filter's point is higher than the original painted one, we're fine. It will output into the inside filter. And then we just want to grab one of those available points. So from here, we can just drag out and use a random choice. A random choice can do a fixed mode or a ratio. In our case, we want to go fixed mode, specifically grab one random point. So this chosen point will be the destination. So now we can finally right click and go pathfinding. And now we can use the pathfinding node. Depending on your values, you're going to want to change the search distance. I find with the values that I'm using right now, 30 distance for searching is good. This primarily depends on your sampling count here. If your search distance ends up being too small, it won't reach to any of the points. If it's too big, there's no real need to sample then that densely. So figure out what works for you. Again, I'm just using what kind of worked for me. I'm going to have the start locations input enabled and the go locations input enabled. And then I will take the pathfinding points, and that is going to go into our in here. The start will be the painted point. That is our start. And a random chosen point here will be the goal. There's one other thing that I want to modify, because this will just still take the best route from one to the other. I want to change the cost function mode. I want to change from distance to fitness score. Basically, what this is going to do is that it's not going to just find the best route. Maybe some of the points around it are cheaper or more expensive to traverse, and so it's going to diverge and make it a little more random. That's it. But still, the start and the end will still be the same. Now, it does take an attribute. Thankfully, that is very easy to do. All we'll do is just drag out, search for a density noise, and then we'll plug that all the way through into the in. All it does is create an attribute noise that is set to density that is from 0 to 1. And now in the pathfinding here, the cost attribute here, we can hit the plus button and go to point density. So this is great. This is no longer going to go directly to the source. The last thing we want to change here is this output to spline. I'll go ahead and disable it. Now, we will be making it a spline down the line, but I found that by disabling it, I can now scale the points before creating into a spline. So that way I can control the size of that vine, but scaling it beforehand did not seem to work. So the alternative is afterwards. And the output of this pathfinding will be going to the output here of the actual graph. So it's a relatively simple graph here. We're just checking the distance of all the points and then filtering them by a range and making sure that the filtered range is also above the original point. And then we're doing a pathfinding to it. So back in our main graph, I'll throw out a transform points here, because as I said, the points we're going to be using are way too big. And I'll scale it between 0.05 to 0.07. And I'll press D to debug it in the world. But because it's so small, I'm going to change it to absolute here on the debug. And I'm going to put in something like 0.2 so we can really see the points. And when I do that, you will see there's our points. If I go ahead and click somewhere, it is going to grab and draw out a new line of points just like that. And as you can see, a little bit more varied. Now, one thing to note here that's happening is is you can see this one is actually going behind into the other mesh. So unfortunately, that is something that can happen, but all you do is just erase it and place a new one. And depending on your randomness, you'll have it go in the correct direction. Just like that, we now have pathfinding for all of these. Awesome. So let's go ahead and create the main vine. Because like I said, from here, we'll just go ahead and use a create spline node that now that we've scaled it, and then using a spline mesh spawner, we can spawn the mesh that we want. In my case, I will just be using just the base cylinder here. The main thing here is I'm going to overwrite the material because I want to put my own and not the base one. I'm using just a mega scans material here. That's a little green. And then I'll close the spline mesh descriptor, and under spline mesh params, I'm going to change the forward axis to be Z. That's because in my case, the cylinder is facing upwards. So that is the Z axis. So I wanted to go forward in that axis. And when I do that, you will see there's our mesh. Well, you can see there's our vines, nice and small, and it has a little bit of movement and randomness to it, which is really nice. Again, click anywhere and you'll get a new one. And by the way, if I turn off the transfer points by hitting E and disabling it, that is actually the size of the cylinder, which is why we want to scale it lower. This doesn't look great, does it? Let's go ahead and press E and re-enable that, and we're good to go here. So with the main vines done, we now want to do a new distance check. I want to check, again, using the original points that we have. Out of all of those that we're sampling, find me ones that are next to those splines. I basically want to use those splines as a filter. There are several ways of doing this. You can use the splines themselves and make them bigger using overlap, or you can use distance again. I'll show you the distance way, so it's a little more exact. But just know that if you wanted to, you could take the points, roll them, and just do an overlap. Where they overlap, that means they are in range. I'll go ahead and use a distance node here though. Again, spatial distance. We want to go again from the merge points as our source. The target will be these transform points. And then just like before, we'll use a point filter, which again is a filter attribute by elements. It's all pretty much the same setup here. But the thing here, we're going to check that I want to only go less than our distance. So I want only the points within this distance. You can do less or equal to as well. Doesn't really matter. The main thing here is I'm going to use a constant threshold, and I'm going to specify I want it to be within 50 units. And if I go from inside filter and do a debug here, and we zoom in one of these, you can see there's the points that are around the vine. And we can go back here, there's the vine, points around it, same thing here, points just around the vine. The other areas don't exist. Click and create a new one, again, points around the vine. In our case though, it is a little bit too many points, so we'll just use a simple select points node to filter out a few. I'll keep only 20% by putting a ratio at 0.2. So now we have far fewer points, and now what I want to do is from every single one of these points, I want it to reconnect to the vine itself. But for that, each one of these points needs to find the closest point on this vine relative to it. So by distance, where is the closest point along the spline? So once again, we'll use a distance node. So let's take the distance and just duplicate it here. So from all of these points as our source, figure out the distance to the original spline points. The main difference here though is on this distance node, we're going to change it to output distance vector. So if I press A on this distance now and scroll to the right, you'll see we have distance X, Y, and Z, which means we have the vector in the direction that it is. It is that much further in X, Y, and Z specifically. And that means because we know how far it is in every single axis relative to the current point, if we take that information and add it to the point's position currently, we will know where it is that it found the connection point to the spline. So from here, we just do an add attribute here. We'll plug the output here into both A and B. And I want to have input source 1 here to be the point position. And I want to add the distance. And it's going to go ahead and output it back onto the position. So effectively, we now have the final location where it connects. So we've taken the original points and effectively made a copy of them in the new location. If I go ahead and press D on both of these, it'll be hard to see depending on the size of it. But you can see there's one of the points, and it's probably from here and from here. Both of these probably found this point as the closest one. So we are going to need to kind of combine these. So once again, from the select points here, I can drag out and search for copy attributes. And I actually want to have select points going to the target and the source. Because what I'm going to do is store the index for input source. I'm going to tell it to be an index. And I want to store it onto an attribute called index. It doesn't matter what it's called here. We can call it whatever we want. But basically, instead of having it a $sign index, it is now a manual attribute called index. If I press A here, you can see on the left here is the original index of the points, but on the right is just an attribute now, exactly the same as the other one. But the reason we're doing this is because we can now do the same thing with these and also copy the points on them. And so the original points and the new points all have this attribute with the same value, which means we can partition by those. So the first thing we're going to do here is do a merge points here, and then we can use an attribute partition. And the attribute partition here is going to be the index. Now this is the attribute index that we've copied to. So if you name this something differently, that's the name that will go in here under index 0. So if I press A here, you'll see each one of these has 2 points. No matter which ones we grab, there are 2 points for all of these. And if I scroll all the way to the left side, you can see the positions of them are different because it's going from one location to another. Some of them are not super far apart, but they're a good distance apart, all of them. If you want to from here, you could do a transfer points again on these and then plug them into the same create spline node here, and you would get something like this. And yes, it's fine. It's not the best thing in the world, but you know, you would survive, but it's very hard. And I don't like these straight lines here. So I want these to also have a little bit of a bend to them. But depending on the sampling, this might be all you're getting. So what I'm going to do is resample the meshes with a tighter density and use that instead. So I'll go back here, remove the transfer points, and we'll continue from this attribute partition, but we're going to need to resample. And to do that, I'll just take the sampling that we did at the beginning and duplicate it here. The only difference here is I'm going to change this constant for the sampling count to be 5. So as I mentioned before, instead of every 10 roughly distance is a point, now it's every 5. So we're getting far more points now. Now we need to do another loop like we did earlier, like this one here, but this new one's a little bit different. It's a little bit simpler. We can go ahead and grab it, duplicate it, and I'll just call this secondary vine. So PCG loop secondary vine, and then I'll take it and just drag it through and create a loop node here. Just like the previous one, the merge points will go into the pathfinding points. The partition will go into the painted points. It's going to throw a warning, but that's fine because we'll go ahead and open it up. And we actually don't care about pretty much almost anything here except this pathfinding node. So we'll delete everything, keep the pathfinding out. The pathfinding points will go all the way through. And then on this loop once, we're going to drag out and search for get attributes from point index. Index here is 0. So we want the first point. And I'll duplicate it, plug it into the painted points. And this is going to be index 1. So the first is going to be our start. The second will be our goal. We can plug all those in. And now on this one, I'm going to change the search distance here to be 20 because we've changed the sizing of the points. I'm now decreasing also how far it's searching. And I'm also going to reset the fitness score back to distance. I just want the closest one at this point. The distance there isn't very far, so it doesn't need to do all of the fitness score stuff. And now with this one, just like the other, we'll grab ourselves a transfer in points. This one's going to be a little bit smaller than the other one, so I'll do 0.025 to 0.04. And then I want it to spawn the same thing as it did before, so I'll have it go in here. Now I could do this where it goes all the way through, or I can keep that in the original area and then drag out and add a named reroute declaration node. I'll go ahead and press F2 to rename it to secondary vines. And then I can go here to the spawn main vine, and I'll just right click and do secondary vines as a search, and you can plug that into the create spline. And then I'll just rename this comment to spawn vine. And now we take a look. Well, that's a lot better, isn't it? These ones now have a little bit of bend, and that feels a lot better. So if we can click anywhere now, and we'll get new ones with new bends, just like that. Now, depending again on the distance, you might get a little bit of intersection into the mesh. That is all dependent on the actual sampling that you're doing. More sampling would be more exact, but of course, a little more expensive in terms of performance. And when I say it's more expensive in terms of performance, I just mean that you'll get more spline meshes. So now that we have these, let's go ahead and spawn stuff on these secondary pieces here. I want leaves here on these and flowers. So right before we did the secondary vines and transfer points, I'll just move this a little bit down. I'll add a new transfer points node. I have the scale between 1 and 2, and then I'll hold the M button down and left click M like Mary, or right click and search for static mesh spawner, and that's what you want to grab and plug in. And on this one, we're going to add some mesh entries with some leaves. I have 4 here that I grabbed. Now these are from Megascans, but I have a little bit of an issue. If I come here and open one up, as I move forward and back, it rotates. I'm not sure why it rotates like the way it does, but it is rotating. And by default, if I zoom in on it, you will see it goes into the super low res view. And when I zoom out, it goes back to normal. normal. I don't know why, but the easy fix that I found, at least one that works relatively well if you were to use one of these pieces, is in the detail panel, I changed the minimum LOD from 0 to 1 and stops doing that. It still does the rotation, but at least it doesn't go super low res. And I did that for all of the actual different vine pieces here. And now if we take a look, that's what we get. I'll go ahead and accept at this point, and we can take a look. There's our vines. So the main vine doesn't have any spawning in them, but the secondary one does. And because there's enough points there, we have different ones kind of stacking together. We have some nice green ones, some nice flowers, and it kind of looks nice overall. And again, if I want to, I can go back to the paint mode here and then hold shift and erase any that I don't like. For example, if I don't like these, I can erase them and then click a new one, and it will go ahead and draw a new vine here. And then when I'm happy, I hit accept. And there we go. We have our new vines. Now there is one thing that is left to actually fix here. It is done. It is working. I can click as I showed, but if I erase all of these points, all of a sudden this whole thing is covered in leaves and flowers, and we don't want this. But as soon as you click one, it works properly on that one. So let's just quickly fix that. It's a very easy fix. This is just happening because on the main graph, we're using this distance mode that is using the source that guarantees it's always going to have some kind of information because it's no longer culling if nothing is in the target. So all we need to do is from this attribute partition, from these points, search for the word count, and we want to do a data count. But basically, this will return how much data it has. And as long as it has data, as long as we've drawn something, we want it to continue. So all we're going to do is right click, search for branch. And we're going to open it up, and data count is going to go to output to B. It is, if it's nothing's there, it's going to return 0, which is going to be false. But if it's true, it has some kind of information, it'll be output to B, in which case I want to do merge points into this in, and output to B, it goes into this distance node. So it will never make it past this beginning part if I don't have anything drawn here. And now you can see there's absolutely nothing here anymore. And now I can click and still get my vines as I did before. But if I have everything erased, it is nice and clean as it should be. There you go. That's the simple fix for that. And now your one-click vine setup is complete. You can, of course, expose things, as I mentioned, to give it even more control dynamically. But basically, you just drag in your volume, you make a tag for the things you want to draw on, and you go ahead and click and draw on them. You can add in a volume where you kind of erase things you don't want. You can customize this to be quite a lot bigger than it already is. I, of course, leave that up to you. But as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, all the links will be in the description down below as always. And if you're looking for more awesome Unreal Engine 5.7 PCG tutorials, check out this one right over here that goes over more awesome PCG mode goodness.